First page of your notes. Hopefully you can see, I am not an artist, but hopefully you can see that you had like a triangle that was folded in the middle, and that's what that figure is. Does that make sense now, when we talk about it? That that's a triangle that's folded, and instead of having one triangle, we now have two triangles. And so we're given that angle EFD and angle EFG are right angles, and that segment ED is congruent to segment EG. We want to prove that segment DF is congruent to segment GF. And let me do that. Okay, so that's what we're trying to prove, that DF is congruent to GF. Doesn't matter what it looks like. We have to go based on what information we're given. So it's always a good idea to mark your diagram according to what you're given. So I'm going to try to mark that I have these right angles. I have a right angle here, and then I have a right angle here. I'm also told that segment ED is congruent to segment EG. Any direct way to get to side DF and side GF based on what I've been given?
No.
What might I need to do, Elise?
They're the last sides remaining. If all those others are congruent, then
EF is congruent to EF,
I don't know
so
what to say.
So, do I need to prove the triangles are congruent?
No, you just need to prove that side.
EF equals.
Well, how can I get to that side if I don't have triangles?
You can't.
I can't. So yeah, I think y'all are thinking along the right strategy. Your strategy. So sometimes it's good to talk about the strategy before we start writing things down. But we don't want to skip steps. So we always start with our given information, or almost always. I guess there's times you don't have to do that. But let's start with the fact that we have right angles. Angle EFD and angle EFG are right angles. And that is simply our given information. Now we have right angles. If I look at those triangles, what kind of triangles are those? They're right triangles. If I have those are right angles, then triangle EFD and triangle EFG are right triangles. And that's just definition of right triangles. All right, we're given some more information. I know something about an angle. I'm given some more information about some sides. We're told that side ED is congruent to side EG. And that's given. Okay, in that right triangle, what's another name for side EG and side ED? What else might we call that knowing we have right triangles?
The hypotenuse.
It's the hypotenuse. It's the hypotenuse. Right? Side ED and side EG are both hypotenuse of the respective right triangles.
What does that mean?
I don't know. What does that mean?
The longest side.
And the hypotenuse is always
Opposite
the right angle.
opposite the right angle. All right. So we do have a theorem that talks about the hypotenuse and the leg, right? To prove congruence. Do we know anything about any of the legs? They share a leg, don't they? What leg do they share? Okay, so we could say that segment EF or side EF is congruent to side EF. Andrea, why can I say that?
Reflexive.
Reflexive. Do I have enough information to prove my triangles are congruent?
Yes.
So if we, what reason can I use to say they're congruent?
Side angle side.
Is it side angle side?
Or can you do the HO postulate?
Hypotenuse leg postulate. Because we have the hypotenuse and we have one leg. That we do not have an included angle. And we said we can't use angle side side. So triangle EDF. Well, I'll do it the same way I did it before. We'll say triangle EFD, since that's how I stated it before. EFD is congruent to triangle EFG, and that is by the hypotenuse leg. All right? I'm asked to prove that side DF is congruent to side GF. Can we do that now? We can, because we have corresponding parts of congruent triangles are congruent. So we just proved our statement. Yeah, that should be a DF. And I can't erase it. It's too late for me to erase it, but I can write over it. Thank you for catching that, Victoria. Okay, so these are the 5 ways that we have worked with to prove that our triangles are congruent. And once we know that triangles are congruent, then we can look at different parts of the triangles to prove maybe that 2 sides are congruent that weren't given to us as congruent, or that 2 angles that weren't given to us are congruent, if we know the triangles are congruent. And we can do that using the definition of congruent triangles. Remember that definition was corresponding parts of congruent triangles are congruent. And we said that you could use a, what do we call that, a mnemonic to help us remember that. You don't have to write it out, but we can use CPC, should have written out triangles, TC. For your reasoning, CPCTC. That can be your reasoning to show that corresponding parts of 2 congruent triangles are congruent. Once you know the triangles are congruent, then we can use CPCTC to look at different parts of those 2 triangles. And that's what we'll be doing on some of the proofs today. So let's just consider if I have a figure that looks like this. And we will call this A, B, C, D. And I'm going to say that AD is parallel to BC. And then DC is parallel to AB. And let's draw a diagonal. And I'm going to just label the angles that are formed. 1, 2, 3, 4. All right, let's look at this. Is there any way to prove that these triangles are congruent?
Yeah.
What would we do, Peyton?
The congruent lines, we do that 1, 3.
Okay. So angle 1 and angle 3 are alternate interior.
4 and 2.
And 4 and 2 are alternate interior. And what reasoning or what would we have to say to justify that? Definition of alternate interior angles. So if we know they're alternate interior angles, then what can we say, Connor? Okay, if we know they're alternate interior, then we can say that they're congruent. Yes, ma'am?
Do those arrows mean that they're like parallel?
Mm-hmm. It's not easy to write with this thing, but yes, we first learned that if you had those little filled-in arrows, that meant that the lines were parallel. And then angle 4 and angle 2 are congruent. And what allows us to say that?
Definition of alternate interior angles theorem.
Alternate interior angles theorem. So we're going to have to be doing some proofs, so we want to be sure, well, that we are able to justify. So we've got the alternate interior angles theorem. What else do we need to prove that these triangles are congruent? Yes?
You need a side, but since AC is a side for both of them, due to the reflexive property.
Okay, AC is congruent to AC, so we have the reflexive property, and therefore those triangles are congruent by,
Angle side angle.
Transitive because of congruent. Right?
reflexive.
I thought reflexive.
Well, but reflex, no, you're thinking substitution. So AC, segment AC is congruent to segment AC, and that would be reflexive property. And so triangle ACD is congruent to what triangle?
CAB.
CAB. Is he right? The order right? Okay. And that is because of what?
Because of the angle side angle.
Angle, side angle. All right. Now, if we know the triangles are congruent, then we could say that angle B is congruent to angle D by the CPCTC. We could say that side AD is congruent to side CB by the CPCTC. Or we could use side CD as congruent to side BA by the CPCTC. Right? Make sense? All right, let's look at a proof. So let's you've got your notes there. Okay, we're just going to talk about this. The perpendicular bisector theorem. You want to be sure you get it copied sometime before we have a test, which I think is week after next. We'll have a test over all of Unit 5. Okay, this tells us that a point is equidistant from the endpoints of a segment. We're looking here at segment AB. So a point is equidistant from the endpoints of a segment if and only if the point lies on the perpendicular bisector of the segment. Now the perpendicular bisector, and we'll talk a little bit more about this next week, but it's going to intersect the segment with a right angle and it at its midpoint. So we have a perpendicular bisector here, XY, segment XY is the perpendicular bisector of segment AB. That means that every point on segment XY is equidistant from the endpoints of segment AB. So segment PA is congruent to segment PB. Segment XA is congruent to segment XB. And then segment, if we had a point here, make sure we could even, well, we already know it's intersecting at the midpoint if it's a perpendicular bisector. So by definition of perpendicular bisector, we know that CA is congruent to segment CB. All right, let's look at the next note card. Again, this one needs to go in your note card sometime if you want to have access to it, just as a reminder. The note cards are for your benefit when it comes test time. Okay, this one is the angle bisector theorem. And it tells us that a point lies on the bisector of an angle if and only if the point's equidistant from the sides of the angle. And I think you can probably read it in your notes. It doesn't show up on the board, but the distance from a point to a line, when we're talking about distance from a point to a line, we're talking about the perpendicular distance from the point to the line. Right? The perpendicular distance. So if we're told that ray BD bisects angle ABC, that means that angle ABD is congruent to angle CBD by definition of an angle bisector. So the angle bisector theorem would then tell us we can make the statement that segment PQ is congruent to segment PR. So let's look at the last sheet of your notes. We've got another proof we want to work through. All right. Here we're given that line DB is the perpendicular bisector of segment AC. And we want to prove that angle DAE is congruent to angle DCE. Now what I've done is shaded that in so that hopefully you can see that's like a three-dimensional figure. It's got a triangle on the base, and then it has sides coming up. So hopefully you can see that. But it's a three-dimensional figure. And I forgot to put, we were going to put a E here at this point. Let's label that E. Because I forgot to put it in your notes. We'll label that E. It is in yours? Oh, good. It just didn't get on the one I sent to the iPad. Okay, so we're told that line DB is the perpendicular bisector of segment AC, so that means this is a right angle, and these are congruent. And we want to prove that this angle is congruent to this angle. So in order to prove those angles are congruent, what does my strategy need to be? Joe?
You need to prove that the angle's going to. I'm not sure.
Matt?
Prove that the two triangles are.
Okay, our goal, we've got to prove the two triangles are congruent before we can prove the two angles are congruent. So let's see what we can do to prove that those two triangles are congruent. All right, so first of all, we'll start with our normal given statement that line DB is the perpendicular bisector of segment AC. How does that help me?
It's a right angle.
Okay, we know it's a right angle where it intersects AC. That B, it's a right angle.
Wait, why isn't the other one right angle?
Because it's not intersecting segment AB there. It's not the perpendicular. You have two different segments. How does a perpendicular bisector segment, how's that going to help me prove triangles are congruent? What does a perpendicular bisector segment theorem say, Mary Helen? You can go back and look at it if you need to. What does it tell us? The perpendicular bisector segment theorem. Okay, so we're told that line DB is a perpendicular bisector. So D, E, and A all lie on the perpendicular bisector, right? What does that tell us then about segment DA and segment DC? They're equidistant from the endpoint, so they are congruent. Right, so for step 2, we could say that segment DA is congruent to segment DC. Do we have any other segments that fall in this same category that lie on the perpendicular bisector? Gabriel?
Just DA and EC.
segment EA is congruent to segment EC. And that is because of the perpendicular bisector theorem. Okay, so that gives me two sides of the triangle. I either need an angle or a third side. What can I get?
Can we do the, no.
DE is correct to DE because it's shared by.
Okay, we have a shared side, so side DE is congruent to side DE, and that's because of reflexive property. Are my triangles congruent then? We could say that they are congruent, and so let's just use the same order that we're trying to prove. We'll say triangle DAE is congruent to triangle DCE by what reason? Side postulate. All right. Can we now prove the angles are congruent?
Yes.
All right. So angle DAE is congruent to angle DCE, and that is because of CPCTC. So the hard part is it's been a while since we've really done a lot with proofs, so it's just getting our mind back to justifying every step with definitions and then being able to use the theorems and the postulates.
Wait, when are we gonna be done with proofs?
Never,
When you graduate from college.
when you die.
We're going to start doing some trigonometric proofs in trig in just a few weeks. So, all right. So your assignment is on page 309 and to 311 to 311, 1 through 6, 8, 9, 17 through 19, and finish the warm up. You just had 1 through 12. That's all you have to finish. Some of you are already done. But finish the warm-up 1 through 12.